This fraction goes on forever, so are we going to need a supercomputer to figure out the exact value? If we try and start calculating this directly, we're just going to get a very messy fraction. And of course, however long we go on for, we're never going to go far enough because we cannot compute an infinite sum just by adding each of these fractions. So what can we actually do to evaluate this? So we're going to use a property of self-similarity here, where if we just said this whole thing is equal to x, then because it goes on to infinity, this part is the same thing as the whole part, which feels really weird. It feels wrong to say that. But what we can do is replace this, because the whole thing is defined as x, and because it goes on to infinity, this part is the same as the rest of the whole thing. Once we've removed that layer, we can just replace this with an x. And now, of course, this is a relatively straightforward quadratic to solve. It's not going to factorize nicely though, so we can use the quadratic formula. So we get the two solutions, 1 plus or minus the square root of 5/2. Those are the two solutions of the quadratic. But if we look at this, I think we can say that this is going to be positive. So we get the one answer to x here, where x is equal to 1 plus root 5/2. You may recognize this as the golden ratio. So this is a general pattern that you can use to solve questions like this. Whenever we have an infinite sum and it's nested, whether it's fractions or surds or whatever it may be, we look for this self-similarity, then often the question actually just becomes a quadratic equations question. If you like this, send it to a friend who finds maths boring.